Let's see current densities in semiconductor. Current densities in semiconductor. In semiconductor, we have two types of current densities. First is drift current density, which is mainly because of electric field, and second is diffusion current density, which is due to the concentration gradient of charge carriers. So first let us see what is drift current density. For electrons, J and drift is Q n mu n E, where Q is charge of electron and n is concentration of electrons, mu n is the mobility of electrons, E is the electric field. So this is sigma n into E, where sigma n is the conductivity of n-type semiconductor, that is n q mu n. Now for holes, drift current density Jp drift is Qp mu p E, and that is equal to sigma p E. So conductivity of p-type semiconductor is Qp mu p, where p is the concentration of holes, mu p is the mobility of holes. So the total drift current density is denoted by Jt. This is sum of electron and hole drift current densities. So the expression for total current density is Qn mu n E plus Qp mu p E. So Gt is Q n mu n P mu p E, and this is sigma T, total conductivity. So this Jt is sigma T E. Sigma T is 1 by rho, make it rho T. So where rho T is the resistivity of semiconductor, so the expression for resistivity is 1 upon Q n mu n P mu p. Now if semiconductor is intrinsic semiconductor, for intrinsic semiconductor, N P is Ni. So the intrinsic conductivity is 1 by rho I, that is intrinsic resistivity. This will be Q Ni mu N plus mu P. Now next is diffusion current density. Let us see diffusion current density. For holes, for the case of holes, Jp diffusion is minus Q dp d by dx px. See, the diffusion current density is mainly because of concentration gradient, and this dp by dx is the concentration gradient. Here this dp is diffusion constant, and dp by dx is the concentration gradient. This diffusion constant is also for holes. Similarly, for electrons, current density is Q dn d by dx nx, where this d by dx nx is the concentration gradient for electrons, dn is diffusion constant for electrons, and dn by dx is the concentration gradient for electrons. Now we have Einstein relation that relates diffusion constant and the mobility. dp by mu p is equal to dn by mu n, and that is equal to kt by q. And if we substitute the values of k and q, then this relation is sorry, this relation is T by 11,600, or this KT by Q is also denoted by Vt, that is called volt temperature equivalent. And at room temperature, the value of Vt is around 0.026 volts. Now let us see, if we have a semiconductor with the concentration gradient, or semiconductor in which one side of semiconductor, this is side 1 and this one is side 2. In one side, side 1, concentration of holes is P1, and in side 2, concentration of holes is P2. For electrons, N1 and N2, and potential of side 1 is V1, potential at side 2 is V2. So now there is a difference in the concentration of charge carriers in side 1 and in side 2 in the same semiconductor. Now due to the difference in concentration, charge carriers will flow from higher concentrated area to lower concentrated area. Now but there is no external connection, so the total current has to be 0, but there exists a flow of charge carriers from one side to another side. Means there must be something to oppose this flow of charges. So due to the flow of charges, an electric field is induced that will oppose the flow of charge carriers, and that will make the total current 0. Here total current, I am considering the current due to holes only first, and then we will derive the condition for electrons also. Total current is hole diffusion current plus hole drift current. Because of no external connections, total current has to be 0. So this is 0. Hole diffusion current is minus Q dP by dx, and hole drift current is Qp mu p E. This E is induced electric field that will oppose the diffusion of charge carriers from one side to another side. So this is Qp mu p E, that is equal to Q dP by dx. Now we know that intensity of electric field is negative gradient of potential. So E is replaced by minus dV by dx, and here we have dP by mu p, dP by p dx. Now dx will cancel each other, and dP by mu p is volt temperature equivalent. So dV is minus Vt dP by P. Now taking the integration in both sides, in the left side limits are V1 to V2, and in the right side this Vt is constant, Vt is independent of P, so integration of 1 by P, lower limit is P1, upper limit is P2. So this is V2 minus V1, that is V21, and in the right side we have Vt, integration of 1 by P is natural log of P, lower limit P1, upper limit P2. So now this V21 is minus Vt natural log of P2 by P1, or simply V21 is Vt natural log of P1 by P2. So this P1 by P2 is e to the power V21 by Vt, and P1 is P2 e to the power V21 by Vt. Now we can derive the similar relation for electrons also. For electrons, Jt is Jn diffusion plus Jn drift. Total current density is 0 because there is no external connection, and whole drift current, sorry, electron diffusion current is Q dn by dx plus electron, sorry, okay. So total current density, I don't know what's the problem. Total current density is 0. Jn diffusion is N, not N again. Diffusion current density is Q dn dn by dx, and electron drift current is n q mu n e. So this is n q mu n e, that is equal to minus q minus q dn by dx. Sorry, intensity of electric field is replaced by minus dv by dx dn by mu n, and 1 by n dn by dx, and this dn by mu n is Vt. So this is dv minus Vt dn by n. Taking the integration, so this is v1 v2 minus Vt integration of 1 by n from n1 to n2. This is v2 minus v1, that is v21 minus Vt natural log of 1 by n with limits n1 to n2. So this v21 is Vt natural log of, sorry, integration is natural log of n. This is n1 by n2, or we can write n1 is n2 e to the power minus v21 by Vt. Now if we take the product of the two equations 1 and 2, this will give P1 N1 equals to P2 N2, that is mass action law is equal to Ni square.